All right, everyone. I am here with Srivathsan Canchi, Head of Engineering for the Machine Learning Platform at Intuit. Srivathsan, welcome to the TWiML AI podcast.
Thank you so much, Sam. It's a pleasure and an honor to be on this podcast.
I am super pumped about this conversation. We are talking in the midst of reInvent, where we're hearing about a bunch of cool new announcements that AWS is doing, of new things that AWS is doing in the machine learning space. And one of those was their feature store. And it turns out that Intuit is a big part of that story, and we're going to dig into that in a bunch of detail. But before we do, I'd love for you to share a little bit about your background and how you came to work on ML platforms at Intuit.
Absolutely. Glad to talk about that. So my background is in building cloud platforms. So prior to Intuit, I was at eBay, where we built the cloud platform as a service for eBay. And we scaled it from almost nothing running in an on-prem setting to running on an on-prem cloud with OpenStack and Kubernetes. So we were handling tens of billions of calls every day. And my journey to machine learning, it's an interesting history on that. So there is this paper called The Hidden Depth on Machine Learning, where the challenges of running and operating ML models is eloquently described. Many of these operational problems are not new, and they have been previously solved in the web services ecosystem on the cloud platform. So my background in building such large-scale cloud platform systems was a good fit for building an ML platform which solved similar problems in the ML ecosystem.
That's awesome. We could go into a whole set of conversations about OpenStack. We're not going to do that. I was a part of that community for many years and went to many OpenStack summits. And there are some actually interesting conversations to have about, what we saw happen in that community and what we see happening in Kubernetes, and are there parallels and lessons that we need to learn from? But that's maybe something that we can do over beers when we're hanging out, when we can do that again.
Absolutely.
But for now, maybe we can start by just talking about some of the ways that Intuit uses machine learning. I can imagine a bunch. I'm sure our listeners can imagine a bunch. But how do you think about the various ML use cases at Intuit? Or what are the focus areas for the teams that you support with your platform?
Absolutely. So Intuit is on a mission to power prosperity around the world, and we want to do that by being an AI-driven expert platform for some of the tough things that people face with their financial lives, managing your taxes, managing accounts and books, and managing personal finances. So this being the mission of the company, AI and ML is core to that mission, and all the ML models that run on the platform are powering various aspects of those missions. If you are a QuickBooks customer, you might have been exposed to a new capability that will predict the cash flow that you might get for your business in the next 3 to 6 weeks out. This capability has been extremely important, especially in the last 6 to 8 months, because of COVID and all the uncertainty that's been around how small businesses operate. And that is one use case where Intuit's machine learning capabilities are really powering deep insights for our customers and enabling them to make decisions that will power prosperity for them.
And what are the specific types of workloads that you tend to see? Does it tend to be tabular types of data, traditional machine learning workloads? Are you doing a lot with deep learning? What's the spectrum of the portfolio that you need to support with the platform?
Most of Intuit's data is tabular, and you might call it as the traditional machine learning, where we get streams of data from our users who are using our products, and we need to extract features out of that and predict various things such as cash flow forecasting or what help do you need with TurboTax and things like that. We are just embarking on deep learning models, but not a lot of them at this point of time. There are a lot of natural language processing models and document understanding models for optical recognition and so on. So when you have your W-2 and you scan your W-2, we use document understanding models to extract those extract the fields out of those documents.
Mm-hmm. So, there's a whole set of questions that I'd like to ask you about, what your overall platform looks like and, what that journey looks like. But in fact, you'll be speaking at our upcoming TWiML AI Platforms Conference in January and covering a bunch of that. So I don't want to, steal your thunder here in the podcast interview. But, I would like to understand the genesis of the feature store as an element of your platform. What are the needs that, that drove you to start building a feature store in the first place?
So Intuit has multiple lines of businesses which intersect in various ways. So you have the tax business with TurboTax, you have QuickBooks, which is doing the accounting, and you have personal finance with Mint, and now with Credit Karma coming in. Now, all of these streams of data are actually intersecting because a lot of them are about the same customer. Like I, as a person, I have my taxes to file, and I also own a business, and I might have to file for business taxes and so on. So with a lot of these as we were building ML models for servicing these different systems, we were discovering that we are building similar features because of the data sets are highly intersecting. We have a lot of features that need to go across these systems and be shared between models across TurboTax, QuickBooks, and Mint. So in order to be effective at sharing such features, we needed a way to do that. So that was the genesis of building typed feature store, so that we can then have features that are well described and typed. So I can have a registry of features that if I'm a new model developer, I can go to the feature store and say, hey, what features exist in the feature store? Let me take a look at these features. Are these features good enough for my models? Or if I need to change any one of those features, I can make the changes to those features. Or if those features are not sufficient, I can go ahead and add to the feature store and add new features to the feature store. So overall, today we have 8,000 plus individual features that are stored in our feature store. And we see about 15 billion feature updates every day to the features in the feature store from the various feature processors who are modifying those features.
Mm-hmm. Is there so feature stores offer several different benefits to folks that use them. You mentioned kind of feature discovery and eliminating rework and folks creating the same features over and over again. There's also issues around productionalization of the features and consistency. And for you and your users, is any one of those or the others the main driver? Is it all of those? Is it always all of those? Like, how do you think of the, why folks, should invest in a feature store? And is it one size fits all, like, or does it vary a lot with the folks that you talk to, your peers in industry?
It is very important for models to be trained on the right features. So that is where the feature discovery and feature sharing comes in. Mm-hmm. The next step that's also extremely important is to make sure that my model gets trained on a set of features, and when I'm inferring, I'm using exactly the same features. So it becomes very important for models to be consistent across my training, evaluation, and inference phases. And what we have observed is with the plethora of data sources that are available at the training phase and during inference phase, models tend to get trained on a slightly different data set. It's the same data set, but coming from somewhere else. For example, I might have a data warehouse which I can query for my offline training purposes, and then have a job that moves data from my data warehouse into an online inference kind of a model. The problem with this approach is that you are now creating drift in terms of the features, and these features, though they might start off almost similar, they quickly start diverging, and it becomes increasingly difficult to converge the drift. So that's where the feature store being a single place where you can access the feature store both in an online fashion for online inference and in an offline fashion for training and batch inference, and access the same features the same way is extremely important for model consistency, for tracking things like explainability. It is very important. Like how did my model predict that I should get a credit from QuickBooks, or I should not get credit from QuickBooks? It becomes easy to track those back when you have a consistent way in which the model gets trained and the model is used in inference. So the answer to that question is both. Both of them are important and equally important, I would say.
Yeah, it's interesting to me, maybe kind of referencing back to the TWiML conference last year, a year ago, feature store, some of the, the big and most advanced players in, users of machine learning had feature stores as part of their platforms. But in terms of commercial feature store offerings, there were very, very few. And now the space has exploded like seemingly overnight. Like Tecton is out with product now. They're a platinum sponsor of TWiML AI platforms. AWS just announced a feature store. Google just announced a feature store. You've got Feast, which is an open source offering that is rolling under, collaborating with. Willem from Feast went to Tecton. There are other products in the space. There's just a ton of activity. It's going to be something that we talk about a lot at the conference. Why do you think this is all happening now?
So in large companies, this has been happening for a long time. So when you talk to Facebook and Google, they have the semblance of, and Uber, they have feature stores, and they've built it for their internal use cases. So what we've seen is when the number of use cases and the number of models accelerates beyond a certain point, you start feeling the need for something like a feature store. And different companies have built their feature stores independently for their own internal use cases. And now things are kind of coming to a stage where the broader industry needs it, and there is an acceptance that there is a market for such a thing called as the feature store. Like Tecton grew out of Michelangelo's feature store, which is used internally at Uber, and similarly, the SageMaker Feature Store grew out of what we at Intuit had built and based on our experience. So I think now the market opportunity and the opening is there, and there is a realization that in order to accelerate AI at any company, now the moment you cross the tens of models and you go into the hundreds of model space, you start feeling the need for something like a feature store. The absence of which leads to a lot of duplication within the company, where you need to have groups of data scientists doing pretty similar things, in order to create these features in an online and offline. And not a lot of companies can actually invest that kind of work for doing the same thing more than one time.
That's an interesting thread that I'd like to pull on some more. So, maybe reframing the question is like, how do you know when you should be thinking about a feature store? Sounds like point one is when you're seeing a lot of duplicate efforts and you're seeing folks building the same features over and over again. Are there 2, 3, 4, and 5 on that list?
And when you want to accelerate your number of use cases for AI and using machine learning models, I think.
So your earlier point. So when you have more than a handful, dozen models or so, then it's probably something to be thinking about.
Yeah.
All right. So tell us about your particular journey with your feature store. There's maybe some context there that is worth talking about a little bit. You've been on the cloud for machine learning for a while now. Maybe tell us a little bit about that. And then, what were some of your first steps in building out the feature store?
Absolutely. So the feature store didn't start off as a feature store. So it started off as feature management and feature engineering in the first place, right? Okay. So we wanted to create a simple way for people to use the streams of data that were coming in. And Intuit is moving mostly to a stream-based architecture where you have these streams of data that are coming in, and now you need to make predictions on these streams of information that's coming in. And so you needed to extract these features out. So it started off as, how do we do feature engineering? So there are multiple aspects to the feature management space. So one is feature engineering, where you need to now extract these features. And then once you extracted the features, then the thought was like, hey, we need to store these features somewhere. So then we went ahead and built a rudimentary store for our first use cases. So our first customers were in the fraud ecosystem, where we needed to detect fraud for that was happening on the platform on Intuit, like fraud on TurboTax or on QuickBooks. And so we built a store specifically for storing fraud-related features. And then once that became used by multiple models, it became interesting that the same features would be usable for other adjacent model use cases as well. So that's when we expanded on the feature store and made a version 2, if you will, which was typed and which had very solid semantics around how do you create a feature, what is the feature set. So we created new terminologies around feature sets and features, and now you could start versioning your feature sets. How does the life cycle of a feature set evolve, and so on. That's where we are in that journey right now, where we can define feature sets and in a typed manner, and you can say, hey, this feature is of this type, this feature is of this type, and a feature set can have multiple features from multiple types. And all of these are well integrated with the training and inference portions. So from a data scientist perspective, if I'm training on a model, I can say, here is the feature set that I want you to train on, and the model trains on that feature set. And when I can then push that model to production, it'll be inferring on exactly the same feature set with the same types and so on. So there is a strong typeness to the whole life cycle of a model, so that there is nothing lost in translation.
Yeah. What is the feature store? What did that first feature store for fraud look like?
It was primarily a database with a bunch of tables and integrated with our training and inference, where our inference would basically talk to the database and fetch those features. That was the only features that it know how to fetch, and it would fetch those. It was very rudimentary in terms of how the access was made. So essentially a database query to fetch the features. Subsequent.
Which is not at all uncommon. I find a lot of folks, that's where they start, is either bolting something on top of a data warehouse or database or whatever store that they have. Sounds like you did the same thing.
Similar thing. So you had two. The thing that we did from the start was divide the offline store and an online store. So offline store would be in our S3 and access through Hive and so on. And the online store was in a DynamoDB. And the reason was, for online store, you needed to have extremely quick access, like tens of milliseconds or even less than 10 millisecond type of feature access. So that was a thing that we did. And then we started adding layers on top of it.
Mm-hmm. Mm-hmm. And then some of the integration it sounds like the big maturity step beyond that is a couple of things I heard. Integration with other, the broader part of kind of training and inference. And then also, I heard you mention types and a type system, and thinking back to my conversation with the FB Learner folks, that was a big element of what they did. And you see that in the AWS feature store as well. Like, tell me about why that part is so important, types, and then talk a little bit about the integration you've done across your workflow.
Types are very important because you need to know whether a feature is a list or a Boolean or an integer, because you need to feed that into the algorithm. In somewhere that determination has to be made of what is this thing that I'm passing into the algorithm. If that determination traditionally has been made inside the code, which we write for the algorithm, where you're reading in something and then saying, hey, this is of this type. Like you could have a sparse vector that you need to pass in, and then you have to kind of typecast it in the code. The problem with that works really great when you are experimenting, when you're in your notebook, you want to try out different things and so on and so forth. Operationally, it becomes difficult because now you are spreading that logic across multiple locations. So you have something in your notebook, you have something in your training code, you have something in your inference code. And there is overhead to keep that consistent and to make sure that the type checks that you're doing or the type conversions that you're doing in one area apply equally in the other areas. So a strongly typed system helps with that, because you know that when you're reading a feature set, and that feature set has features A, B, and C, where A is a list of integers and B is a sparse vector, you know that's what you're going to get. And in your code, you can depend on that, and you can actually query for that type from the feature store. And in your code, you can make that typed. And this is also important from a consistency across training and inference. And you might see that that's a theme that on which we have built the platform, because it's extremely important that your training and inference kind of go hand in hand, and they're not diverging at any stage. And having a type system is crucial for that. In terms of how we have integrated it, the feature store with the model lifecycle, we've created a system by which a paved road, if you will, in Netflix terminology, for ML models at the company. And as part of this paved road, you'll be able to specify what features you want in a GraphQL format. And that GraphQL will essentially query the feature store, and it will return back a typed set of features to you. And the same GraphQL is applied during training, and a materialized view of the offline store is produced for the training to use. And the same GraphQL is used to query the feature store service. So the feature store service takes in the GraphQL, and then it goes to the backend database, which is DynamoDB, and queries that and gets back the results. So the model's interface will exactly be the same to the feature store. That consistency is extremely important because from a data scientist perspective, they have to write very few lines of query, and they get this across the board consistency that they can depend on.
I'm starting to see and hear GraphQL being used quite a bit as part of these pipelines in places that we might otherwise have used REST, kind of traditional REST verbs. You maybe take a second to talk a little bit about that, why you selected it and what it does for you?
Absolutely. So the GraphQL part actually originated as an aggregation for various data stores that we had. You might have, and it started off not just for the feature store, but for other data stores as well. Then as we built the feature store, we thought that this is a great interface because it provides us a way to in a GraphQL semantics, have a well-defined schema that can be written to. And I think that's very important in a JSON type of a structure. You cannot enforce a schema. You can say that, hey, this is my schema for my input and my output, and you've got to write parsers for it to deserialize the output as to read it. But with a GraphQL, you get the tools. The ecosystem is rich because the moment you can say, hey, this is my schema, and now you can generate clients for that schema in multiple languages, and makes the integration much easier. For an example, our integration for training is with Python, and for online inference is with Java. But then it's the same GraphQL query that gets used and talks to the service for that.
And so you started building this feature store. You had a couple of iterations of it. When did AWS come into the picture? I mean, you were using AWS as the underlying platform all along, but when and how did they come into the picture?
So Intuit and AWS has a rich history together, and great partners, right? So AWS powers all of Intuit, 100% of Intuit, and they've been amazing partners for us in all respects. And we've been working with AWS since the early days of SageMaker, when SageMaker was not called SageMaker and something else. And we've been working with them very closely as they built out their online inference. That was the first thing that we productionalized on SageMaker, was the online inference part of it. Then we operationalized the training part of it, and we've been working very closely with them on the SageMaker operators now on Kubernetes, as SageMaker moves to Kubernetes operators. So we have an extremely close partnership, and we keep them abreast in terms of what we are doing and what the problems that we are seeing. So that's where the collaboration started, as we saw that, hey, we are building this because we have a need, but we would love for it to be a managed service that AWS can provide. And so how can we collaborate? How can we contribute what we have built, or the learnings from what we have? And so that started a series of conversations and design discussions with AWS, and that's how the whole journey has been.
And how close is the thing that you have seen them announce to, something that to the thing that you built? What are the commonalities? Where did it diverge to support a broader set of use cases? How do you think about the relationship between the two?
From a backend perspective, they're quite similar. One of our design criteria was that when we migrate from our internal feature store to the managed feature store, it should not be a big lift for us. So we've
that's easy for you to say, but you have to convince AWS of that.
No, so we kind of work with them, and as I said, they're extremely great partners, and we have. I think we're pretty close to that objective in terms of being able to migrate quite easily, and we will have a migration plan in the next few months to migrate over from our feature store to AWS feature store. I think the secret sauce that AWS brings in is taking this and then offering that as a managed service for a wider set of use cases, and that's where AWS has built all the controls around, hey, how do you run it in any account, and how do you create those interfaces that are common across all their customers. So that's the beauty of having SageMaker offer the managed services. You can take that and generalize it for a much richer set of customers and richer set of use cases.
It sounds like, just reading between the lines, that it hasn't diverged a whole lot from the thing that you built to solve it's a set of use cases at Intuit.
Yeah, they did build controls around how do you cross account access and things like that got added, but the basic semantics are the same. So the fundamental APIs are very similar, very close to each other.
Mm-hmm. And so for folks that don't have a feature store or have something rudimentary, what are the things that you need to think about to successfully adopt something like what you built, or something like the SageMaker Feature Store, or something like another one for that matter?
Mm-hmm. Feature before the step before feature store is the feature engineering part, and feature engineering is hard. So that's one thing that you need to think about. Hey, what are my features, and how am I going to extract it from the data that I have? And I feel that ecosystem is still fragmented because of the fragmentation of the data. With Data Wrangler that AWS has announced, I think that the feature engineering part is going to get much simpler, as you can apply standard transformations and so on. So how am I going to do feature engineering is a question that you have to think about and ponder upon. The second one is how am I going to store the metadata about my features so that they are discoverable and they are shareable across. And what would that metadata be? And the third thing is, how do I share my features? So the features might not be universally applicable across the company. There might be sensitive features that need some controls around it. So what are those controls? How do I apply those controls? The fourth thing is around compliance. What sort of compliance does my data set need to adhere to? For example, you might need to enforce CCPA or GDPR on the data sets, or you might, depending on the business that you are in, you might need to have indoor or NIST compliance on the data and so on. So those are the questions that you need to think about, and as any feature store that you pick, you will need to answer those questions. I think the platforms will provide the capability to enforce some of those policies, but it is up to each individual use case to decide what those policies are for themselves.
You mentioned some work that you're doing around Kubernetes operators, also working with AWS. Tell us a little bit about the background there, and what are some of the problems that you're trying to solve with those?
Totally. Kubernetes, I think in the cluster manager for cloud kind of a domain, Kubernetes has come out on tops, right? I've been involved with the Kubernetes ecosystem since 2014. And at that time, Mesos was king. Like Mesos was really...
for data workload, for sure.
Yeah, data workloads. And they were coming into the web workloads and web services domain as well. Since then, I think Kubernetes has matured at such a fast clip, and that community has evolved significantly that I think that it is now the de facto cluster manager.
Yeah.
What Kubernetes offers is there are two key dimensions in which it shines. Right. First, it provides clear and consistent developer interfaces. Like you have the CRDs that you write to, and they work the same way, whether they're running in your local, they're running on Cloud A or Cloud B or Cloud C, or on-prem. Like at eBay, we implemented it in OpenStack and Google, so you were able to take the same workload and run it across OpenStack and Google. Similarly, at Intuit, we can run the same workload, whether it's local on my laptop or on AWS. The second thing that Kubernetes brings is the ability to run heterogeneous workloads, where you can, on the same cluster, you can run your web service and you can run your data processing workloads. They can share infrastructure, so your overall cost footprint actually gets lowered, because now you can utilize the infrastructure that you already are paying for to the maximum. Like, for example, if you're running a web service which has a seasonal pattern, like in the mornings, during the day, there is a high traffic, and then in the evening, the volume dies down. The same cluster can be used for running your data workloads, which can then pick up in the evening and do their Spark processing or things like that in the evening. The third thing that Kubernetes offers is the operator concept. Right. So with the operator concept, you can now integrate with other systems which offer richer functionality on top of the same cluster. So, for example, popular operators around Spark and Flink, both of which we use at Intuit for our data processing on the same clusters that our machine learning workloads are running. Right. So and now SageMaker, we worked with SageMaker saying, hey, we need to be in this ecosystem. Intuit is going to a 100% Kubernetes ecosystem on top of AWS. And so we need our machine learning workloads to run and coexist with this ecosystem. And that's how the SageMaker operator partnership started happening, where we said, hey, can you provide us a native Kubernetes way for interacting with SageMaker? We do not want to build a control plane that interacts with SageMaker separately, like maybe using Moto3 or one of those other AWS SDKs. We want to be able to integrate natively with Kubernetes, so that we can then use our native Kubernetes tools such as Argo workflows and Argo CDs to manage machine learning workloads.
And so is the idea, is what we're talking about something, that we've seen AWS do in other places, like a SageMaker Anywhere, where you would have this SageMaker operator and you could run it locally in your environment? Or is it, is it the other way around? Is it you using, is it primarily focused on exposing the API to applications and systems that you might have running in like EKS or, on native AWS infrastructure running Kubernetes in the cloud?
So the first cut is for to provide the APIs, right? So to integrate with SageMaker, SageMaker exposes REST APIs. Now they with the operators, they're also exposing the SageMaker operator, which can then take on YAML file and then go and behind the scenes, it's going to invoke the SageMaker APIs to run the workloads. But what this opens up is tomorrow you could run SageMaker anywhere. Like you could run SageMaker on your Kubernetes cluster. You could run SageMaker on the edge, for example. You can have like a micro Kubernetes edition, and you can actually run things anywhere. And your interfaces are not going to change, right? As an ML practitioner, I'm going to write to a very standardized Kubernetes-based interface, which the SageMaker CRD defines. And at that point, I do not really know where it is actually running. I can build tools around it. I can build my practices around it, knowing that that is going to be my interface. And when SageMaker evolves, maybe it can run within EKS in my own namespace, then I'm going to reap those benefits without me having to actually do a lift and shift of how I am doing things.
Mm-hmm.
And the other thing that SageMaker Operator provides is also an easy access to new capabilities as SageMaker evolves, right? For example, they recently introduced this thing for multi-model endpoints. And how do I, if I have to access multi-model endpoints now, I may need to build something, integrations with Boto3 and all of that to actually start invoking that. With the operators, the benefit is now I have my SageMaker YAML file, which was maybe 100 lines long. Now I have a section that's 20 additional lines that I add there, and boom, I got multi-model endpoints. So from a customer standpoint, as a customer of SageMaker, it makes it trivial for us to keep up with the releases that SageMaker is doing and translate those benefits back to our customers who are our data scientists within the company.
Mm-hmm. And so you've not only saved having to write those endpoints using Boto3 or some other API, but they're resilient endpoints also, because Kubernetes is making sure that there are the correct number of replicas and all that good stuff that Kubernetes provides out of the box.
Absolutely. Yes, absolutely.
Very, very cool. Very cool. So where do you see this whole kind of feature store, landscape going? Not necessarily even the landscape, but in terms of the kind of capabilities that you need and expect, and your users need and expect, and that will become required in the industry. Where do you see all that going?
I think feature store is extremely important, but an underlying, it's like a foundation for the ecosystem, right? What would need to happen is to build tools around the feature store. An early example could be the data wrangler work that AWS is coming up with. Kubeflow has good integrations with feature stores like the Feast feature store. So tying the whole ecosystem together, like how do I go from data to features to trained models to models that are producing great business outcomes? Tying that together with these components is, I think, very important. And I feel that's where the industry is headed towards. You see a lot of activity on Kubeflow, for example, with Kubeflow pipelines, which is trying to get this end-to-end orchestration kind of going. And MLflow has great dashboards where you can actually visualize the how your model is going through its life cycle. I think a combination of these is still lacking, and that's where the opportunities are in future.
Awesome. Well, Srivathsan, congrats on seeing what I can only imagine is your baby, out in the world now. It's awesome, and looking forward to your presentation at TWiMLCon about more of what you're doing in the platforms operationalization, productionalization space. And thanks so much for joining us to share a bit about the feature store.
Thank you so much, Sam. It has been a really pleasure to talk to you about our journey, and I really looking forward to presenting the internals of the Intuit ML platform at the conference.
Awesome. Thank you.
Thank you so much.